So good afternoon,
Okay.
everyone. My name is Francesco Petruccione. I'm the director of NITheCS, and I'm sorry that I missed the first two lectures of Sunday in this very exciting introductory course to programming in Python. Today is the third of four lectures, yeah, and it will be all about loops and lists, yeah. So that will be very, very exciting for most of you. So Sunday, you don't have much time, so please just start. And I see you have lots of students patiently waiting for your wisdom. Yeah. So
All right.
please go
All right.
ahead.
Thank you, Prof. So welcome to today's session. I'll turn off my video because of bandwidth issues for others, so that we have a smooth class. I'll do that just now. Okay. All right. So welcome to today's session. My name is Sunday, as introduced by Professor Petruccini. And so for today's class, we'll play with loops and iterations. But before we go into today's class, we'll do a quick recap of what we did in our last session. In the last session, we played with arrays. I showed you how to, play with arrays in Python, and more importantly, we looked at conditionals. Conditional statement, we looked at else if statement, we also looked at elif statements, and then we ended the class. I promise that also in the previous class, we looked at examples. We played with a couple of examples, and then I said, in today's class, we look into one more or two more examples with respect to conditional statement, and then we then proceed into what we have today. So I will share my screen. Just give me a moment to share my screen. All right. So I hope you can all see my screen. And if you can you kindly give a thumbs up? All right now. Okay. Thank you. And let's start. Let's start with the elif. This is just a quick recap of what the conditional statement we played with last time in our last class. So we play with the example. We play with just two examples. Now for today's class, this script is already in the Google Drive shared link. So you can, if you all have access to that link, to that Google Drive, click on it, you'll find this particular script in that shared folder. For those who don't have that, I'll try and see if I can share that. Just a quick one. Let's see. So it's in there already, and so you can. So we did not get the script for the script is already in that shared. Kindly check and confirm it's in there already. I will share the link with you right away now so that it's in there. You can, if you have the scripts, kindly give a thumbs up. If you have access to that Google Drive link, kindly give a thumbs up so that I know it. All right. I'll share the link. I'll share the address here just now for others. Let me quickly do that. So to everyone, there is the link. You'll find today's script and the previous script for the last two sessions are in here in the Google Drive link. So let's move on to our example, the number sign example. So the concept here is to enter a number, and we want to determine, the point here is to decide if it's a positive number or it's a zero or a negative number, right? In our last class, we looked at the input keyword here, functionality in Python. And then that allows you to, enter a number or a text depending on what you want. And so for this particular example, we will play with the elif statement and the else. Recall that we start with the if statement and then the condition. And thereafter, we have a column. And the next line will then, gives us the action statement. And in our case, if the number we enter is greater than 0, and then it then moves on to the next line, then that means it is true, it moves on. And if not, if that particular number we enter or the digit is not less or is less than 0, then it goes to the next line and see, oh, is it equal to 0 or otherwise? Remember that this sign here is the equality sign. In Python, you have double equal sign. When you have a single sign, equal sign, like we have highlighted here, it doesn't refer to equality. Indirectly, what that means is it's an assignment symbol, assigning a value to a variable. We played with that in our last two sessions. Let's try this out. Let's try this example out. But before we try this example out, the first thing you do is you load your libraries. And for this session, we'll be playing with the numerical Python library, NumPy. I'll run this. And that's fine, it's good. We have a green tick here, it's okay. And then we go back to our example, number sign example. So you click on the button and it prompts you to enter a number. This prompt is based on because we have this input from keyword here. And then it prompts us to enter a number. We played with this in our last example. If we do not run the libraries, will the arithmetic not work? That's a question. So the NumPy helps us to, perform several numerical operations. So without running that library, you may not be able to carry out some certain functionalities. Fine, you would be able to do 2 plus 3, the basic operations, addition, subtraction, but you wouldn't be able to do certain numerical, you will not be able to carry out certain numerical functionalities. You will see in our next two examples what I mean by this. Where do we get the recordings? The recordings are on NITheCS website. It's on the website. I would share just before the end of today's session. I'll share the link with you. So we run this, and then it prompts us. I'm back to example. It prompts us to enter a number. Can you open a library? Can you open the library load slide again? Okay. So This is it. Import numpy. So we are particular about this. Import numerical Python. Import numpy as NP. And so it prompts us to enter a number. You can take a screenshot and then you do the rest because of time, right? So we enter a number here. Let's enter a number 90. And then you press the enter key. So it gives us a positive number. And how did that? The first thing it does, remember that this number 90 is now stored in the variable called number. And then the next line looks at the condition. It looks at the variable and the value within that variable called number, right? And compares it with 0. Now, the variable number has a value 90. And in other words, what it does is to compare 90 and 0. 90 is greater than 0. That's a true. The statement is true. And then it moves to the next line and it prints positive number. Let's run this again and assume that we have a number. Let's enter -7. And then you press enter and it gives us a number. If you have done this, give a thumbs up and so that I know you're all here together. Give a thumbs up and then, okay, great, fine. All right. What happens if you enter 0.2? You're free to try it. You can try it. Okay, let's quickly try that. That's a question from Zolili. What happens if you enter 0.2? I'll try that again. I'll run the line again and then let's try 0.2. But before we run this, let's look at what happens here. So our number is 0.2, right? And that means that what we're trying to do in the first line, we are assigning 0.2 to that variable, number. So that value is assigned to the variable called number. And it goes to the next line if number is greater than 0. Now we know that our number contains the value 0.2. It does the comparison. 0.2 is greater than 0. And then that's a positive number, right? And so it should give us, so someone says, what if enter the invalid literary for int with base 10 0. So what happens there is, let's look at this. Because of time, I'll quickly run through this so that we don't waste our time. All right. So someone says input should be an integer. Yes, you are right. That's the bottom line here. But it's quite much more than that. And then, but I'll address this at the end of the session so that we don't waste our time with this. This is not the core focus of our work today. Someone said something good. Does decimal points work like? Yes, good point. Does not like decimals. But remember, we said something about floats, and that's why I said I would take this. I would address this at the end of the class. Remember, we said something about floats, right? And that's why I will address this at the end of the class so that we don't waste our time. We have quite important stuff to do. Okay, so let's run this and it gives us a positive number. But let's quickly move on to the next example, and then we move on to iterations. Okay. So let's play with coins. Let's toss coins. Now we want to toss coins manually. So if for instance, if the coin lands on heads, then let's assume we have two players here, Liseho and Tabo. So if it lands on heads, then it's Liseho wins. And if the coin lands on tails, Tabo wins. We can do this using conditional statements. So if we replace info, you can try that. But let's quickly move on. So let's assume in our heads, and we use a string here, heads. Let's assume the heads is saved into or assigned to that variable called coin. And we run this. So the first condition here is if coin is equals to heads, then Liceo wins. But as it stands, the coin already has the value heads. So if we run this, Liceo definitely will win. But however, if it's otherwise, right, then Tabo wins. And that's where I want, let's quickly run this. Now, Tabo, Liceo wins. But let's change this to tail or something else. And this is what I want to show you. Now, I purposely have this in capitals and not in small letters. So our coin now has been assigned to that variable, the value, this string has been assigned to the variable called coin. The tail here, the value has been assigned to the variable called coin. And then the next line here shows the comparison. The first thing it does in that underline is to see the value in coin. Is it the same as heads? But we know that this tail is not the same as heads. So that means this statement becomes false, right? And then it jumps to the next else. What it does is immediately prints Tabo wins. So in other words, this code, let's run this first and let's see what it is. Now Tabo will win, definitely. If you have tried this out, can you give a thumbs up and then move on to do just one more explanation with respect to that. Okay, so why is it that even with a capital tail spelled, our tail spelled in capitals, right? Tabo still wins. It's because that we didn't specify in the else statement exactly small letter tail. So any other thing other than the heads here, any other thing outside head comes in the else statement and then it prints Tabo. Simply what I'm saying is that if this statement, the first statement, is not true, then it comes to the next else, the else statement here, and then prints what is in the action statement. Are there questions with respect to this before we move on? Okay, see thumbs up. Give it thumbs up if there are no questions, and we can just proceed to one more example. Let's play one more game. And this example speaks to the question that was asked earlier on. Must we load non-numerical Python or must we load the libraries? Now, in this case, like I said at the beginning of today's session, we're working on the numerical Python library. There are several libraries, matplotlib, Seaborn, TensorFlow, several stats library, SciPy, and stuff, and many. But for this example, for this class, we will be playing with the numerical Python, and we just don't want to, unlike in the last example, we don't want to do it manually. We want it to be random. We don't want to choose the coin, the value of the coin or where it lands. We want it to be stochastic. In other words, we want it to happen randomly, right? And for us to do that, we would make use of numerical Python's random functionality. So there's a function within random in numerical Python. It's called choice. It helps you to randomly choose between 0 and 1, or a tail or a head, right? And that's why we have this coin NP. Remember our numerical Python random generator, my favorite. Okay, I've always been fascinated by the Sleeping Beauty problem. maybe that could be incorporated. Maybe in our, I would note that, and so that it will be part of our project in our last session. Sorry, in our next session. So let's play this game again. So what we have here is we randomly generate the heads or tail, and then we decide if that value is heads, if Lisero win, and if it's otherwise, Tabo win. So let's play it one more time. Now Lisero win. Let's play again. Lisero wins again. Tabo wins. Tabo wins. Lisero wins. Tabo wins. Tabo wins. So we can play that. If you play this game and you have it, can you give a thumbs up before we move on to what we have today, which is quite important. Loops and iterations. All right. Okay. So in the last example, where we randomly generated using random.choice, we randomly generated the coins. Is it an head or a tail? And you recall that I was pressing often and often again just to play, that's like a repetition, right? If that is a if you believe that clicking this and often one more time, trying again and again is a repetition, give a thumbs up. If you agree that that is a repetition, give a thumbs up. Okay. Now that is why we need loops. You don't want to be doing it yourself. Assuming I want to do it 1 million times, it becomes tiring doing that, pressing the run button every now and then. We don't want to do that. So in Python, we call that, when it comes to repetition, we call that loops. We say that's a loop, right? So you want to carry out an action over and over and over and over again. Why do we need loops, or why do we use loops? To save time, to write less code, and to work with lists and different data types. You would see what I mean by this in the next period in subsequent examples. So a loop repeats an action multiple times. A loop repeats an action multiple times. So that repetition in programming is called iteration. So if I repeat an action 10 times, that's an iteration. The number of iteration is 10. It's an iteration. So that repetition is called an iteration. So I wouldn't say multiple times. In programming language, in programming parlance, we say iteration. So there are two types of ways to go about this. Generally, two types. If you understand what an iteration is, give a thumbs up in that so that we proceed. An iteration is a repetition. Loops are for repetition. They help in save your time, they say rewrite less code. They help you to work with a list. Okay. All right. So how do loops work? Let's leave out what is on the screen, and you will see how it works. It looks at you start. It requires an action, right? And then you carry out that several times. You carry out that action several times, depending on a set condition. That set condition could be the number of times you want to repeat the action. Now I'm using those basic words, simple words. So it depends on the condition, depends on the number of repetition. In other words, the number of iterations. It could also be a condition. If this is greater than this, and run the iteration, run it until the condition isn't satisfied, right? Okay. So generally in programming and in Python, we can do this via two approaches, via the for loop, via a for loop statement and a while loop statement. For loop and while loop. These are basic ways of how to approach iterations. Okay. I'll quickly explain in just 2 bullet points the differences between these two. When do we use for loops or for statement? Or when do we use the while statement? Now for loop, you use the for loop statement when you know the number of times, to repeat the action. So when you know how many times to repeat an action, it could be 20 times, that is defined, right? 15 times, it's definite. 21 million times, 10,000, those are category, it's specific here, it's defined. But what if you don't know? You want to stop an action, for instance, it could be um, keep the door open until it is 7 p.m. when you think people would have gone home or left the building. And then, so that's a condition, right? We don't know when, but that's also sort of tricky. But for while loops, you use, or we make use of the while loop when we don't know how many times in advance. It could be, for instance, when there's no one in the building. When there's no one in the building, close the door. Could be 7 p.m., it could be 9 p.m., it could be 8 a.m. in the morning. As long as there's no one in the building, no one knows, right? So with for loops or for the for statement, it is defined, it is specific. We know the number of times for repetition, but for while loop, we don't know in advance. So let's play with the while loop, with the for loop. Before we move on to the for loop, if you understand this basic concept of for loops and while loop, can you give a thumbs up before we proceed? Someone, Mohammed, saying, what is a random generator? So a random generator, um, I don't want to go into, okay, so if you've played you played, let's say, okay, so you have between 0 and 1. Let's say you have 0 and 1, and then you close your eyes, and then, okay, or you have two cups on the table, you close your eyes, you pick one, and then you drop, and then you pick one randomly. So, by chance, right? That is what it means, by chance. So when you generate numbers by chance, it follows the concept of chaos theory, but there is also an orderliness within that chaos, or within that stochasticity. So it's random generator, produces or creates or generates numbers, or by chance. It follows a specific pattern. Okay, so let's move on to the for loop. This is what the for loop looks like. You start with the for. Let me make this bigger a bit. So you have a for statement, just like when we did the if statement, right? The if statement, remember, we call if statement. Now we have the for, and we have an index, and we have a range. And then later on, we have this action statement. But let's break this down into keywords before we start running the codes. Okay. So the keyword here is for. The for, it's unique to for loop. And we have an index variable, right? Remember that we said it for for loop, it's defined, the number of times you repeat the action is defined, right? So with this index variable helps you to keep track of your counting at each point in time. So if we are to count from 1 to 1 million, and we're at 100, then our high becomes 100. The index variable becomes 100. Now, in is also the keyword here, and then we have a range. The range is a function that generates number. Recall that when we looked at arrays, we looked at a range. We had two ways of creating arrays. We have the A range and the linspace. The A range, I said something about automatic range or something. Now it's similar here. So we have range 0, range 5. What it means is you generate an array or create an array that starts with some 0, 1, 2, 3, 4. Recall that 5 will not be included, right? And then we have the next line here, the action statement. The action statement is the print or the action body. In our case here is the print. So what I will explain what this what this means. For I in range 5, print high. Okay, so the range here starts from 0, 1, 2, 3, 4. What it does, it starts from the first item in that array, element in that array. It's 0. So our high becomes 0. And then it moves on to this second line here, it prints 0. It goes back again to the for loop. Our next element in that array is 1. And then our I becomes 1. It prints, it comes back to the action statement. It means print I. It prints 1. And then it comes back to the for loop again to the first sentence, for first line. The next element in that array is 2. It comes back, and then our high becomes 2. It comes back to the, and it does this until it gets to 4. And then we have 5 elements, and then it prints 0, 1, 2, 3, 4. Let me show you an example, and then this it has been proven that nothing is truly random. Yes, Letiwa. The random generator also is based on chaos theory, and even within the chaos, there's also orderliness within the chaos. Okay, so let's start with the basic example. Let's print hello 5 times. The word hello 5 times. Before you run this, let's look at this line carefully. We have a for statement. Keyword here is for, and our high, which is the index I. Now, I chose that my index variable with I. You can make yours B. You can make yours whatever you want. It could also be, it could be a string as well, right? Just a text. And then my range here is 5. That means my counting starts from 0, 1, 2, 3, 4, 5. 1, 2, 0, 1, 2, 3. So what if, and this is for you guys now, I want you to type this in the chat box. What if I have 1,100 here? How many times will my iteration run? I want you to type that in the chat. 99, 98. Okay, it runs 100 times. I will explain why. I mean, it runs 100 times, and you would see. Yeah, good. It will run 100 times. So someone said 99, but remember that 0 is included. It only stops at 99, but 0 is also included. So let's play with this. Let's play with this particular line. Now I want to run this 100 times, but this will take forever, so I don't want, because of time. I want my iteration to run 10 times, but what do I want it to do for each iteration? And that's what the next line comes into play. Now, and then my action point is the print keyword. So print is a keyword in Python, and then we have a bracket, and within that, because I wanted to print a text, that is a string, right? And remember that strings are always in quotation marks. And that's why I have this. For when you use your for for statement. It is similar to what we have when we looked at the if-else statement. It also respects indentation. The indentation here is similar to the if-else statement. Sunday for print should one tab get syntax. Yeah, you use two tabs each. So I guess syntax it should be twice, and then you would, yeah, it should be under, yeah. And so we run this print 10 times. If I change this to 3 times, it prints 3 times. What it does is it looks at the first array. So the range helps to create an array 0, 1, 2. In this case, I have range of 3, 0, 1, 2. It picks for the first iteration, it picks 0, and it comes into the action statement. It said print elu, and it prints elu. It goes back to the second element in the array. The second element is 1, and it comes back to the print as action body again, action statement. It's only print hello, and it prints again. And then until when you have, it covers all the elements within the array. So let's do this again. So let's print numbers. Let's print numbers. Let's print numbers. This is similar to when we created arrays using np.arange, right? Now, we want this iteration to run 5 times, but our counting now starts from 1 and ends at 5, 1, 6. This is similar to NPA range. So it starts 1, 2, 3, 4, 5. 6 is not included. And so it looks at the action statement here. Now it's print the index. What's the value of the index? So if we start with 1 for the first iteration, our I will be 1, and then it goes to the action statement. It says print I. What that means is now it prints the value within that index variable, and we start with 1, so it will print 1. And then it goes back to the array again, This is 1, 2. It picks 2, and then it prints I, and now I is 2. It prints 2, and it does that until it covers all the elements within that array. Mine didn't run. It's because ensure that you load your libraries at the beginning, and then you ensure that if you are typing on your own, you follow the indentation. If you have tried examples 1 and 2, can you give a thumbs up before we move on to the second example? This is now we're doing a bit of an arithmetic operation. Now we're looking at, thank you so much. So we're moving on to the next example. We're building on what we have here. So we just don't want to print I. We want to carry out a multiplication operations. So we want to multiply whatever we have in our index variable by 2. And that's what we have here. Still the same code, but I've included a multiplication here. Now, please note that there is no quotation here because we are dealing with, we are not dealing with strings or text. We are dealing with numerics. For numerics, you don't need quotations. We look at this, and then I'll explain this again. So what it does, it looks at the first index variable, which is 1. It multiplies it by 2. We have 2. It goes back to that array. The next one is 2, and then it multiplies 2 by 2, and then it goes back to the next array. We have 3. It comes back to the action statement. We have our high is now 3. It will be 3 multiplied by 2, and it does that until it gets to the last element in that array, which is 1, 2, 3, 4, 5, 5. Now it multiplies 5 by 2, and then we have 10. If you have tried this out, give a thumbs up before we move on to another interesting example. Yes. So yes, because okay, this is a question for someone asked. It seems like the code goes through the first action, print hello for I equals to one, and then but then on the screen appears. It appears as if all the actions are happening simultaneously. Now, is it possible to delay the timing so we can? Yeah. So it does this sequentially, right? But it will appear, because of it takes quite the computational time is quite very, very small, so it will seem as if it appears once. So when we debug codes, or when we then put breaks in, and then we see this stuff happening one after the other. Because of time, I won't be able to show you this, but I promise that I will create this a script and then also drop that in to show you how that is being done. But it does this one. It carries out this operation sequentially, one at a time. But because of the fact that the computational time is quite small, um, okay. So let's move on to. We just don't want to carry. I want to show you that we we don't only we can also carry out iterations with respect to um, list as well, or when it comes to arrays with strings and the likes. So in this example, we want to run through the list. Assuming we have a list of 1,000,000 fruits, and we don't want to be going through, we want to print it out. We can use the simple concept of iteration. Now, for this example, we have a list, right, with fruits, and we played with this in our first, remember our first class or our first session, and we're playing with text strings, otherwise called, text. And then, so we then look at, now this is important. Now remember, recall that I said our index variable you can name it whatever you want. So now I've named my index variable fruits. I can name it whatever I want. It can as well be high. It can be J, it can be K. But the point here is we're still looking at our array. And our array here, rather than creating an array using range, because we are not dealing with numbers here, we are dealing with a list. And the list has been defined as up here as fruits. We just indicate the name of the array, or the variable name holding the array. And then we run this over and over again. And someone says, remove the quotation. What's happening here? Now print I, I've printed. So what we're doing is I is, please remove the quotation. I without the quotation means something else. Yeah. So okay. So if you've been able to play with this, I'll leave the two other examples, and then I'll leave these other two examples. Sorry, the last example is similar to what we did in the just now. If you have been able to play with this, can you give a thumbs up before we move on to while loops? Okay. So you would notice, before we move on to while, you will notice that we're building on our previous sessions, right? In our previous sessions, we looked at strings, we looked at arrays, we looked at how to create arrays, and now we're playing with those stuff now. Okay, all right. So let's look at the while loop. So I told you earlier on, I shared with you that we have two approaches to iterations. We have the while loop and the for loop. You use the for loop when you are certain the number of times you want the iterations to run is defined. That's for the for loop, right? But for the while loop, I said we are not sure. We are not sure. That's when we use while loop. And I gave an example. Assuming, for instance, as we have a code that that operates the door to a hall, right? And we wanted to open that hall when there are people within the door should always be open when people are within inside the hall. So immediately there's no one in the hall. It senses that there's no one within the hall. It closes the door automatically. We don't know when that will happen, right? No one knows when everyone would leave, and that's why we need a while loop in this. Mine has avocado in the fruit list. Yes, you can do that. Yeah, that's okay. So let's move on to while loop. Let's move on to while condition. It follows the similar to the for loop, but it also comes with a little bit you know niche, and I'll show you where that comes into play. Okay, all right. So for the while loop, we use the while keyword, and then we have our condition, just like for you know we have a condition, and then we have an action statement. The while loop also contains a counter, right? So for the for loop, it automatically counts. There's an automatic iteration, but for the for loop, it doesn't work that way. So you must define a counter that ensures that it keeps running. And let's look at an example. But before we look at the example, let me just run you through this again. You have a keyword, the while. You have a condition that must be met for the iteration to keep running or to stop. And then we have an action loop or action body or action statement. Can you please repeat what you have just said when you explain while loop? Okay. So for the while loop, I started by saying that for the while loop, we really don't. Okay, I'll start with the for loop. So for the for loop, we already have an idea of the number of times the iteration will run, right? And I said for while loop, we don't know. We only want the iteration to keep running, until a certain condition is not met, or it should keep running as long as a condition is met. That condition is what we don't know when it will meet or satisfy or not satisfy this condition. We don't know, right? So that's when we use the while loop. I said for the while loop, it also needs a counter, unlike in the for loop. For the for loop, automatically it picks those elements within the arrays. Automatically does that. It moves from 0 to 1, 1 to 2, and keeps running. But for the while loop, it doesn't work that way. It has a counter, and I'll show you what that means. All right, so let's move on to an example for we know while we don't know. Yes, Mogad, yes, similar to that. Now, it has its own counter, and I'll give you a basic example, and then we look at other examples. Before we move on to the example, can you give a thumbs up if I should proceed or not? Because I would want you to. All right. So thank you. So let's move on to an example. And we'll play with this example before we move on to complex examples later on and then we end the class. So I said something about the while loop. It has a condition. It uses the keyword while, and then you must have a condition. Recall that for our if-else statement or elif statement, we always have a condition. Is it greater than this? Is it less than this? And the likes. And that would also play in here. You might wonder, count. What is count? Now, in this instance, count it serves as it helps the while loop to run through the iteration. It's not automatic, right? So, and I will show you what I mean by this. So I already defined here, based on this example, my one, the variable called count holds the value one. One, in other words, one has been assigned to a variable called count. Now we want to count, we want this iteration to run until for about 5 times, not more than 5 times. That's what this means. Run while the count is equal to or not greater than 5 times. In other words, keep running, run the first time, run the second time, run the third time, the fourth, and the fifth. And that's why we have 5 here. Now look at this, and before we run this code, we now, from what we have here, we've defined the count to start with 1, right? Count owes a value, the variable called count owes a value 1. So what this means here is, while run this iteration while 5 is greater than the value in here in count, and our count is called what? It has a value of 1. And so if that is true, since 5 is greater than 1, right, or 1 is lesser than 5, right, it moves, and that is true, right, it comes into this iteration, it moves to the action body. And what that means is print count, print that variable count. In other words, print 1, because what is in count is 1. And then it moves to the next sentence, next line of code. Then we then add 1 to count. This is called increment. We increment count with a value of 1. It can be 2, it can be whatever, but I'll play with other examples and then you will get to see this. We increment this count at step of 1. And so remember that initially when we were at this point, we had count was 1. So it will now be count plus 1, that is 1 plus 1, that is 2. So now the count now, this variable count now owes the value of 2. It's 1 plus 1, 2, and that value is stored in count. So count is now 2, and it moves back here to this while loop again. And when it gets to this while loop, it looks at this condition. Remember that count now holds the value of 2. And then it carries out the comparisons. If 5 greater than 2, yes, 5 is greater than 2, it moves to the action statement, and then it prints 2, it prints count, but our count holds a value of 2, that means it prints 2. And then it moves on to the next line, and then increments it again with a step of 1. That is 2 plus 1, and that's 3. Then 3 is then saved into that count, that variable count. It moves back, and until it gets to 4, until it gets to 5. And when it gets to 5, it doesn't, or when it gets to 6. So when it gets, for instance, when count is 5, right? What happens is 5 is still, this is not greater than 5, and it's true. It prints it, and we have 5 here, and then it increments it. It moves back here. However, that count now becomes 6. Then it doesn't fit that, it doesn't meet or satisfy that condition. 5 cannot be greater than 6. Then it's false. That means our iteration stops at that point. Let's run this and see. Now we have a value of 2. Let's change our count. I want to play with this as well. Let's make this a step of 2. Right? And then we make this 50. And let's see what happens here. So it starts with 2. Recall that our count starts with 2 now and then keeps printing. But I can change this step again to 3 or 5, and then you will see the difference. It starts from 2, then it will be 7, it will be 12, it start adding 5. If you have tried this out, can you give a thumbs up before we move on to other examples? Okay. Now the other examples, I'll just play with one or two more examples, and the others you can look at it. Okay. We want to use the concept of for loops to create a simple multiplication table. I recall in my kindergarten days, uh, was it grade 2 or grade 3 now? So you play with this multiplication table. If you have played with this table before now, if you've encountered simple multiplication table in your high school, or sorry, your primary school, or can you give a thumbs up before we? If you've done 2 multiplied by 3, 1 times 2, and you do the recitation, and yeah, okay, if you have tried that out, yeah, is it grade 2 or grade 3? Okay, now we want to do this, but we don't want to we want to use concept of for loop to do this. We want to multiply, we want a multiplication table, with respect to five times, right? So let's start with our plan is to multiply 5 times 1, 5 times 2, 5 times 3, 5 times 4, 5 times 5, 5 times 6, 5 times 7, and until 5 times 10, or 5 multiplied by, So what you notice, what changes here is 1, 5 multiplied by 1, 5 times 2, 5 times 3, 5. So this is an increase. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. That's like an array, right? So we can create an array using for loop. So we are going back to our for loop. We know the number of times now. We go to for loop, we use an I as our index variable. We create a range. Our range is from 1 to 11. Assuming we want this to be 12 times, and we want it to stop at 12, we make it 13. And then we do this. We play with this, and we have that. So what happens is it keeps multiplying the number. Remember, we've defined number as 5 here. And then it carries out this multiplication. This is what I want you to focus on. Number multiplied by high, and it does that. Let's play with one more example, and this is similar. I just want to play with the input here. You should be the one to define your multiplication table. It's similar to what we've done. I want to make this 5, and it gives us 5 times 1, 5 times 10, and the likes. You can define what you want. I can make this 4 times, press enter, and then you have this. If you've played with this, can you give a thumbs up? Now, you may wonder, why didn't I type all of this? I want you to go on your own after this class. Look at this code carefully. We have other examples. I've particularly left out the double for loops. I want you to think about this. We don't only use a single loop, we can use a loop within a loop. A loop within a loop is called a nested loop. I'll give a brief recap of what we did so far in this class. In today's class, we looked at elif examples. We looked at 3 examples. We also looked at a random np.random.choice example, in order to randomly generate the tail or head. And then I showed you, we played with that, and then we move on to conditionals. I explained why we can't, to use conditionals. It's easier, it saves time, it saves codes. You can keep pressing the run button 1 million times. So we don't use conditionals. And when you repeat items, it's also called in programming or in Python. Generally, it's called iteration. And so when you repeat 1,000 times. That's an iteration thereabout of 1,000 times. So we approach this in Python and generally in programming using two approaches, the for loop and the while loop. I explained the for loop when we use the for loop, when the number of iterations are defined, they are specific, we know the number of times we want to run a simulation or iteration. And for while loop, when we are not so certain, but we then set a condition. We played with examples, and then lastly, I showed you examples of multiplication tables. And I would want you to, go through these examples and someone asks, do we have the idea of do while we carry out an action for before? Yeah, so some of this stuff, I promise to include two scripts into this, into the Google Drive, but not today. Tomorrow, I will do that to address some of these questions that were asked. And because of time, we don't really have time. This is a 1 hour class. Thank you so much for your time. If you have questions, pop it in and we can always address that. And then I'll hand over to Professor Francesco. Okay.
Sunday, thank you very much. It was again an excellent introduction to Python. I can see there are lots of compliments that are flowing up the screen. So everybody seems to be very, very, very happy about that. Yeah. I think people interacted a lot in the chat. I see there are 2 raised hands. Are you happy, Sunday? Do you have a minute to answer the questions that come verbally?
Yes,
Okay,
I
then
can.
I allow Nzwaki and Wendy to ask their questions in person, and maybe Nzwaki can go first. You just have to unmute yourself. Okay, maybe it was a false raised hand. Maybe Wendy wants to go. Wendy, if you have a questions, just unmute yourself. Okay, maybe.